Since this has turned into a bit of an electronics thread and nobody has really complained or doesn't seem to mind, I thought I'd just share with you my latest project. So essentially what I'm trying to do is create a GASA, which is a petrol helicopter monitoring system for its charging and battery status, if you like. So this is representing the fuel, the gasoline, if you like. This is representing the carburetor, and this would be the engine in here. Obviously not mounted on the heli. It's just here for the testing. But this bit would, so this dog would be mounted on top of the engine, and so with this motor for the charger. Just note while we're here at this point that I've got a magnet there, which is feeding for the RPM, so we can detect RPM. It comes down here into this three-phase regulator, which feeds into this Castle Creations BEC. I'm using a 20 amp Castle Creations BEC. Simply because this particular one allows me to adjust the output voltage in quite small increments, which is ideal for tuning the circuit. I'm using a What's Up meter here just so as I can see the output of the BEC, which comes around here and through into this diode. Now the diode is normally in circuit, because what you'd find with normal circuits like this is they would put the LEDs or the lighting system here at this point in this diode, and that's really so it doesn't get any feed from the battery when the battery is connected. So in other words, the LEDs in a normal circuit would only light if we've got some generating a voltage, if we're generating a voltage out of this BEC. Now the reason why I don't like that idea is that if this BEC is producing just a slight bit of voltage, just enough to actually light up these LEDs, but not enough to charge the battery, it can give you a false positive indication that your battery is actually charging when it's not. So I'm going to turn that around the opposite way, and just like with a car with the ignition light, these will come on only if there's a problem. So what else are we doing here? We're not just doing that obviously with this massive circuit, which obviously needs to be a little bit smaller. What we're going to do is we're going to monitor ambient temperature. We're going to monitor the engine temperature. We're going to monitor the inside the canopy, which can get quite warm on a GASA temperature. We're monitoring the voltage produced by the three-phase rectifier here. Around into the circuit, we're monitoring the voltage produced at this point here. Monitoring the RPM. Now the RPM is coming down here into this circuit, but also this K-bar has been modified, and this wire here is using to say that, well, I can connect that orange wire to that yellow wire there, and also use the same sensor for the governor for the K-bar, but also to feed back into the circuit. This circuit needs to understand what the RPM is, because it can't work out if there's an error if it doesn't know whether it should be producing any current or not. So the idea is for example, in this scenario, we've got 600 RPM is enough to generate enough voltage here to start charging and powering the circuit, and it only kicks those error messages into play should we get over 600 RPM. All that comes back obviously into the K-bar, but more importantly, it comes back onto the FrSky receiver, and through the S-port sensor sends it over to the Tranos. Let's just turn the Tranos on. So what we've got on the Tranos here is we've got just put the shit in here. So we've designed a screen here. So we've got the cell voltages. We've got an output here to say is the generator spinning, what's the voltage the generator is producing, and what's the output voltage of the BEC. We can also see the engine temperature, which at the moment I'm using this temperature sensor because this is the only real part here that gets warm. So I wanted to obviously display on here. We can see that we can get the RPM back. We've got an overall status, and this part here does scrolling text messages, if you like, of what the error states are.
Telemetry lost. Telemetry recovered.
So if I go into, for instance, let's go out of that and go back into the telemetry screen, what we can see is that under this section here, where it says 0 RPM and you've got a 0, this would show you the number of any errors that might occur. I'll show you that in a moment. But first of all, let's go ahead and just use this servo tester to start spinning the engine, if you like. Okay, so the engine started to spin. You can hear this, as you can see there. The engine started to spin, which spins the charger. coming down into the three-phase rectifier, as we said, through into the BEC, creating a voltage on the BEC, not quite hitting the 7 volts yet, or just below 7 volts. Now, the reason I want to point this bit out is now, on a conventional circuit like this, the LEDs would be lit, because you've got 6.55 volts, although it's doing absolutely nothing to charge this at all. As you can see with the current being generated. So as you can see, my LEDs are out. Let's go ahead and add in the servos, which is this very crude contraption here, 4 bulbs tied together, which will pull about 4 amps through the circuit. I don't know if I can connect that into this circuit without putting the phone down, so just forgive me while I do that. You'll hear the RPM slow down a bit as it tries to produce more power. There you go. So we're just going to increase the power there. That's similar to when you turn on the air conditioning of the car, of course, and you get less miles per gallon because you've got more energy pulling. So if we now go back to our screen here, we can see now we've got a generator voltage of 6 volts, just managing to get 6.53. Got an RPM of 329 RPM. So if I turn that up a bit, you'll see that the generator voltage starts to go up. And we start producing a better voltage, if you like, from the BEC. Status is still showing okay. LEDs are not showing. The bulbs are lit up as we're producing the current. Let's simulate a bit of an error. I'll only be able to show you the LEDs light up. Unfortunately, it won't do a text message here, but I'll be able to show you that it is sending back to the Taranis. So if I unplug these, again I'll have to put the phone down, I think. You hear the thing come down, and I'll unplug this one too. And then the LEDs have come on to say there's an error. As I said, I've not got this bit programmed yet, so I can't do that. But if I show you, if I go back to the error, hang on here, what we've now got is the 99 means it's on a pause cycle. So error 2, error 5, 99. It waits a bit so we don't get a lot of errors scrolling up the screen at any one time. Now, the processing of those error messages are all coming from the Arduino, and the reason for that is the Arduino is taking all I'll turn this off a little bit. The Arduino is taking all the processing power, so the Taranis, if you like, is only acting as a slave to display the errors. Now, of course, I've lost telemetry because I've got no battery plugged in, and the LEDs have gone out. Just to prove actually that the heli would fly even without the battery connected, if I start charging, then everything will start booting up, the lights will light, and the governor, or the charger, sorry, will feed 5.2 amps to keep the thing in the air. And again, I could now just plug this in like this, put the battery back together, and eventually the LEDs will just go out. It waits to check to see if the voltage is now stable from the battery, and it clears the error. Obviously there'd still be the errors on your screen here and recorded in the logs on the Taranis. The next step is to feed current, because what I don't like about this, if you look at this, is that the voltage drops down significantly as a percentage wise across the battery with the governor, so it's going to be very difficult to understand in flight what the true percentage of the battery is holding. So the next steps are to actually monitor. I'll turn that down a bit. Disconnect the servos so it don't drag my voltage and my battery down. Okay, so next steps are to actually mount current sensors so I can detect the current coming through here and the current flow from either into the battery or from the battery. And then I'm going to, on a different screen, I'm going to designed something that looks a bit like a hybrid car. So you've got the helicopter at the top, and you've got the battery on the left, and the feed either coming out the battery to the heli or back into the battery, and the governor on this side feeding power to the heli and to the battery, so you can actually see how much current the circuit's taking in different areas, if that makes sense. And of course that would all then be logged on the Taranis. So hopefully that was interesting for you guys. If anybody thinks of any good ideas, let me know. But that's how the design's coming on so far. Cheers, thanks for watching.